Hello everybody, I'm Nick, and in this video I'm going to introduce you to the extremely highly requested topic of outbox patterns in messaging in .NET. More specifically, in this video I'm going to show you the transactional outbox pattern, which is one of the most important patterns you need to understand and know how to use in messaging. In this video I'm going to explain what it is, how it works, why we need it, and I'm also going to talk about some alternatives if you don't want to use that pattern. What other options do you have? In this video I'm going to be using Amazon SQS, which is the queuing mechanism in Amazon, and this video is sponsored by AWS, so massive thank you to them. However, this is not only applicable to SQS. Because we're going to be using mass transit to show all this, any transport or any backing service we'll use, whether that's RabbitMQ or Azure Service Bus or anything else, will work exactly as you see it. Now, AWS has also sponsored a Dome Train course, so if you want to get started with AWS services as a C# developer, click the link in the description. It's absolutely free and yours to keep forever. If you like that type of content and you want to see more, make sure you subscribe for more training. Check out my courses on dometrain.com. Okay, so let me show you what I have here. I have this customers API over here. It has one controller. We can create, get all, update, or delete a customer. And behind the scenes, this is using a database, which I am running here in Docker. And this is a Postgres database to store all the users I'm creating. So if I go over here and I say, run this API, let me show you what I have. And here I can see my database. And as you can see, I have a single user. So if I go to Insomnia, I can say, get all customers. And I'm going to get this customer back over here. So I'm going to get it. I can get a customer by ID. So I can copy this ID and I can go here and paste it at the end of the URL. And I'm going to get it. If it is wrong, I'm going to get a 404. And I can also create a customer, as you can see over here. So let's create Nick again. And this is all created. And you can see the created users. Now I'm going to go quickly and delete these customers. Now, here's what happens in most applications. When you want to create a resource or update or delete or basically mutate some state, which its mutation might be important for some other aspect of your business. For example, when you create a customer, you also might want to queue an email for email verification, for example, or anything else. Any aspect of the business and any team of the business might need to know that the customer was created, updated, deleted, and so on. So you can subsequently, for example, delete more information about them for GDPR purposes or anonymize it. Well, you might need to do many things. Now, I could just go to my service over here and say, okay, here's where I create my customer. As I'm adding them into the database and saving them, I can also say send email. I can also say, I don't know, call some API. I can do many things. But the problem I have here is that this method now is doing too much and I get very slow. And the only thing that's important for the customer is that it was added to the database and that is it. They get the response, they go their merry way, and hopefully my application behind the scenes can do all the other things. Now, people have tried naive ways for years to do this. For example, they're spinning up a background thread and they're putting this functionality in the thread. But what happens if your application is scaled out? What happens if this is a microservice? There's so many moving parts. So a great way to deal with this is to use a queuing mechanism and use asynchronous messaging and either publish an event where people can subscribe and listen to that, or you can just send it to a specific queue and that queue can do something later. For example, queue that email. Now let's see how we would implement something like that. Now, before I move on, I'd like to let you know that we just launched a brand new course on Dome Train called Getting Started with Modular Monoliths in .NET, and is authored by the legend Steve Ardalis Smith. I'm sure Steve has taught many of you already with courses on other platforms like Pluralsight, but now he authored his first of many courses on Dome Train, and it's all about how to get started with modular monoliths. Not only will he teach you the theory behind the concept and how it compares to microservices or traditional monoliths, but he will also build a whole system in that course, hands-on with code and diagrams and examples, and you can follow along. It is an amazing course and it is the best way to get started with modular monoliths, hands down, in .NET. Now, to celebrate the launch, I'd like to offer the first 500 of you a 20% discount, so either use a link in the description or apply code modular at checkout to claim the 20% off. It's a great opportunity to get started with a concept, and I can't stress enough how much of an amazing author Steve is. Now back to the video. I'm gonna go to the program.cs, and as you can see over here, I've already added a NuGet package called mass transit. Now, I've already covered mass transit in .NET in a previous video, so I'm gonna link that below if you want to see how to get started with mass transit. This assumes you sort of understand what mass transit is, but if you don't, all it really is, it's an abstraction layer over queuing mechanisms or pub subs such as RabbitMQ or maybe Amazon SQS, Azure Service Bus, this sort of thing. So you code against a common abstraction, and then behind the scenes, Mass Transit can implement all those other transports specifically. So the only thing that changes is me saying Mass Transit dot Azure Service Bus, for example, to go from SQS to Service Bus and so on. We've seen all of that in the previous video. So now that I've configured Mass Transit here and I'm saying, hey, use this SQS queue over here and configure all the endpoints, all I need to do to introduce the messaging functionality is go to my service and say private read only I publish endpoint. So I'm going to use a publish endpoint here, which is scoped by default in registration. And I'm going to take it and I'm going to say, oh, here's where I want to publish a message, and how convenient, I have a few message contracts over here. So this is the record representing a customer being created. So I'm going to go here and I'm going to say var message equals new customer created, and you can have a mapper if you want. All I'm going to do is I'm going to manually map this user over here. So ID, full name, email, and date of birth. And then what I'll say is await the publish endpoint and then publish that message, and that is it. And that then will publish it into the queue. And just to see all that working, I'm going to stick a breakpoint here and just say debug my application. So I'm using AWS. I have the toolkit over here to see all my messages in the SQS. You can see the queues are automatically created because Mass Transit will do that. And I'm going to go ahead and say create a customer. So send that request. I'm hitting my breakpoint. I'm going here. I'm saying add the user to the database, and then I get my message. And over here, I am publishing that message. So if I go to customer created the queue and I view messages, you can see it over here. It's already published and you can see everything about it over here. And then after it's published, I also save to the database, and thankfully it was saved successfully. And eventually I have, as you can see over here, a consumer. And if you want to grab this code, you can use a link down below to get it for free. But I can go to this worker over here, which has some very similar configuration, and it has consumers for every type of message. In this case, all it's really doing is it's logging. Don't do logging this way, by the way. This is not the right way to do logging. I'm just doing it like this because I want to print something to the console to show that I consumed it. So I'm going to run the worker, and as you're going to see very quickly, we're going to see that the customer created message has been consumed. If I go ahead and I create a second customer, you will see immediately that another request has been fired and it has been processed through a new message. Fantastic, very easy messaging in the app. Now, do you see what the problem is with this? You might have spotted it. The problem is that I'm publishing this message, which by the way, it could also be below the creation. So we sort of ensure that something was created, and only if it was created, maybe, let's say result is more than 0, only then we publish the message, which is a nice safeguard to make sure we don't publish a message for something that wasn't done. But what guarantees that, yeah, okay, this was added to the database, but do we know for a fact that this was published to the queue? We don't, we can't. Yes, there are ways to get around this with distributed transactions and two-phase commits, but this is a very, very hard problem in general in applications, because you can have atomic operations between the database you're using and the message bus you're publishing towards. And then what do? If this failed, you roll back. And what if the rollback failed? Like, this such a big problem and chicken and egg problem you have to solve here. And there's no obvious easy solution. But the truth is, there actually is. It's both very easy to implement and pretty obvious. You see, we cannot have an atomic operation between a database and a message queue, but we can have an atomic operation in a database. You can have a transaction that does many things. It adds the customer, and then it adds the instruction to do something about the added customer. So what, instead of writing in a single table, the customers table over here, we also had a second table called the outbox table, and there's actually more into that behind the scenes, but let's in theory just say we have the outbox table saying that, hey, a customer was created, and then a service picks that up after it's been transactionally written, and it has to push it into a queue, and then that queue is read by a consumer and that is published. So if I was to use a very scientific tool to demonstrate this, I can go here and I can say that instead of writing into a single place over here, which in this case, this is the customers table, let's also in the same transaction, because now we are on a database, like I said, write something to the outbox. Then have something, and we will see what that something is, listen to that outbox and see, hey, do you have any messages for me to process? And then that thing will not only read those messages, but also it is going to publish them, as we're going to see here, to a queue. So take that message and publish it. Now, there is a bit of an issue here where you can have the situation where if this is trying to read from the outbox and then get the message and publish it, what if the publishing fails? Well, you can update the state of the outbox and say that this message hasn't been processed yet, and only say that it has after you guarantee that it is being pushed into the message bus. The usual problem with all this is that in some implementations, you cannot guarantee exactly once delivery with this process. So you need to have idempotency baked into your message processing, meaning that if a message is pushed twice into the queue or consumed twice, your application only makes one action, not two. Having worked in finance, dealing with payments, this was the bread and butter for everything we did. You don't want to have a message or an event handled twice, because if you do, someone might pay twice. And people don't like paying twice if they have only paid once. Now, you could definitely go and manually implement all this, but you don't have to, because Mass Transit natively supports the outbox pattern, the transactional outbox pattern, on top of an in-memory one, which I'm not going to cover. So how will we introduce the pattern here? Well, first, what I'm going to do is I'm going to move this message publishing between the action I'm taking on the database, the addition, and before the save changes async. And I'm going to paste it here. And I'm still saying publish. So the code I have here will publish into the queue. Nothing about the database as it is. Now I'm going to go to my API's NuGet packages, and I'm going to say mass transit.entity framework core. And this is natively supported with Entity Framework. You can just add Entity Framework just for this. You don't have to use it for your whole application, but to simplify management of this whole process, Mass Transit chose to use EF Core, which, by the way, is fine, it's performant, it's fast, it is great. It's .NET 8, we're good. And once I do that, I can go to my AppDB context, and I have to specify in the model that there are some tables that need to be created. For example, I'm going to say override on model creating, and I'm going to add 3 lines. First, I'll say model builder.add inbox state entity, then model builder.add outbox state entity, and I'm also going to say model builder.add outbox message entity. Those 3 things is what I need. And once I specify that, I need a bit more configuration on the add mass transit method. So what I'm going to say in there is x.add entity framework outbox, and I'm going to specify my DB context. So add DB context, some configuration over here, and I'm going to say o.use Postgres and also use bus outbox. And I'm going to leave the defaults for now. I will also specify here in this service o.query delay, and I'm going to set that to 1 second. I'm going to explain what that is in a second. I'm doing this for demo purposes, so we can have all the actions happen quickly. Once I do that, I want to create migrations for this new feature, because there will be tables needed, and these tables are configured through this. So I'll say .NET EF migrations add outbox, and let's get that created. Here we go, migrations created. So if I go here, I can see all the migrations and all the code needed for those new tables. And then I can say .NET EF database update. And once I do that, we're going to get all those tables created. If I refresh the tables, you're going to see inbox state, outbox message, and then outbox state. So that will now handle our outbox pattern. And now that's it. I'm not going to touch anything else about my code, meaning that this publishing, that .publish that's supposed to push into a queue, won't be touched. Now, let me quickly show you what you need to do on the consumer side of things. First, we'll need to add a couple of packages. So first, we need the Mass Transit Entity Framework core package we added in the main API project. And then we'll also add the Postgres Entity Framework Core. Then we're going to create an app.db context. It doesn't have to be the same as the main application. This is just here for the Outbox. This means that there's no other DB context needed in here or DB set. All you need is a traditional model creation. That is it. Now back to the program.cs. In the add mass transit call, we're going to say add Entity Framework Outbox app.db context as in the other application. And here, all we're going to say is we're going to have a duplicate detection window to detect duplicate messages from the inbox. So I'm going to have that as timespan dot from seconds 30. And then I'm going to say, hey, use Postgres, but nothing about the bus outbox, just use Postgres, and that is it. Now for all this to work, I also need to wire up, of course, the app.db context. So I'm going to say add db context as I would normally do, app.db context, and then configure that to use Postgres. And that is it. All I'm going to do now is I'm going to run my worker, which is supposed to be listening to the queues. And as you can see, it is listening to all the queues. And then I'm going to, exactly as it is, I want to remind you, I did not touch the publishing message. What I'm going to do is I'm going to stick a breakpoint and run the API. And let me show you what happens. In fact, I'm going to remove the breakpoint for now. And first I'm going to publish a message. So I'm going to go straight over here into Insomnia and I'm going to say, create a customer. So customer created. A few things are happening here. We don't really care about that. But if I go to the worker, as you can see, we did process the worker because now we have the customer created consumer message and all the details. That's it. So nothing seems to have changed because it still seemed like I just published into a queue. So what problem did I actually solve? Well, let me show you. I'm going to go to the customer service and I'm going to slap a breakpoint on the add async method, which I want to remind you in Entity Framework Core doesn't take any action. It just marks the entity to be added when you call save changes, which again is transactional. So let's go ahead and say create another customer and let's hit that breakpoint. We're marking that entity. And then normally on this publish call, we would publish something into the queue directly. I'm going to step over that. I haven't called save changes async yet, but I want to show you we have nothing in the queue. Let me just save you messages. The queue is empty. And you might expect that because the worker is running, so you're assuming I published something and it's been consumed by the worker. The truth is, it hasn't. There is no message consumption because nothing has been published yet. The moment, however, I say save changes async, then and only then something will happen. And what will happen is in the database, if I go to the Outbox state, you're going to see the state of an Outbox message and all its details. And then in the Outbox message, you're going to see a new entry over here, which just was added with this save async call alongside my new customer, which contains in the body the whole message serialized. So now the moment I say run freely, don't stick to that breakpoint and don't stay there to my service behind the scenes will use a bus running in the background, the hosted service running in the background, and push those messages. And as you can see, it's not here anymore, and push that into the queue. And my worker then will pick it up. And as you can see, it has been processed. That's the whole point of the Outbox. We are doing our action transactionally and we're adding an entry into the Outbox, and then later a service picks it up and it pushes it into the message. So both things happen atomically. It is implemented in a great way in mass transit. It is very simple to work. You don't need to change your code. This all still looks like two independent calls, but behind the scenes, this is all transactional. Now, you could stop that worker service that picks the Outbox and publishes it if you go over here. And just to remind you, this query delay is a delay that the service that will read the messages in that Outbox and take them and push them will have to perform, so we don't just spam the database with many requests per second, basically. So in this whole thing, I could also say that disable that delivery service, that background service logic, because you just want to use the Outbox and you might want to have offline processing. So there's no queue, there's no bus working. You might also want to go further and say, disable the inbox cleanup service. You have full control, and you can even run this service that looks into the database and pushes messages into the queue to run out of this process. So you split that responsibility to another service and then you have the worker that still consumes straight from the queue, but it acknowledges that the outbox exists, so it can also mutate the state as needed. And like I said, if you wanted to use any other provider with any of this, you could easily just go here and say mass transit.RabbitMQ, for example, remove Amazon SQS, wire that up, and the only call that needs to change is the using whatever you want to use, RabbitMQ or any other provider you want. In this case, SQS is what I've used in production extensively, so that's the one I'm using. And that's it. Your code now just supports the transactional outbox pattern. Again, you're going to find all this code in the description down below. It's all for free. And if you have any questions, please leave them in the comments down below. Now, something I want to point out is that this is not my favorite way to deal with this problem. I have a different approach, having worked in the cloud and in serverless for an extensive period of time. We actually deal with this problem differently, and if you want to know how we deal with that problem, leave a comment down below and I will make a video on that. But now I want to know from you, what do you think about this, and are you using something else to implement it? Maybe you're using your own approach. Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.